Okay, so I'm going to talk a little bit about our experience with the Angular router, particularly some of the things that we found to be a little less obvious. This talk is not explicitly migration related. It's based a little bit on our AngularJS to Angular migration, but it's sort of a small section of that. And hopefully the things that I present today will be relevant whether you are migrating or whether you're starting fresh with Angular. So just to introduce myself, I'm Jen Bourey. I've been at Google for almost 5 years now, and I'm currently a tech lead on the Google Cloud Console client infrastructure team. I was one of the original instigators of AngularJS adoption for Google Cloud, and I'm currently leading the Angular 2 migration. So just to put our project in context a little bit, Google Cloud Console is the unified web console for Google Cloud. So we have all the configuration UI, if you wanted to create a VM, all that good stuff. It is a really big project. So we currently have about 500,000 lines of code, just source code, and then we have another 500,000 lines of test code. And that's just the client side stuff. There's a lot more in the back end. So it's a really big project to manage, and we get into a lot of really interesting issues with scale and complexity. So we've had a lot of interesting experience working through that, particularly with the router. I'm feeling a little bit guilty tonight. I did not walk my dog and I passed that responsibility off to something else. So in his honor, I have created a little pretend test application that is dog themed. And there are many dog pictures, so hopefully you will enjoy that. If not, sorry. Okay, so the first thing I'd like to talk about is keeping requests under control. So that includes things like keeping downloads small and avoiding unnecessary requests and making sure that we don't have too many sequential requests. One of the best ways to do that is by adopting lazy loading. And this is one of the things that's really nice in Angular that was kind of missing in AngularJS. So we had rolled our own solution in AngularJS. It worked, but we had to maintain it custom. It was a little awkward to set up. The Angular version is actually really easy to work with. So this is kind of what our application looks like in Angular 2 right now. So we have the core module that downloads along with the main page. And then from there, we download different routing modules depending on which top level section you are. So if you're at like the compute section, you would get the compute routing. And then from there, we actually have one lazy loaded module per page. And part of the reason we're doing that is some of these pages have heavyweight components that even if the pages are related to each other, they may have really different dependencies. So for example, we might have a list page that includes some sort of heavyweight table component that includes things like sorting and filtering. Whereas on an edit page, we might have a lot of form components. And on the detail page, perhaps we have a bunch of charts and things like that. So we want to make sure that we can optimize our users' experience by sending as little as we need to for the browser, especially for mobile use cases. So imagine we translate this concept to my little imaginary dogs app. So these are the sample app routes that I'm going to be talking about tonight. So we have a list of all of the dogs in our system at /dogs. Maelstrom, my dog's name would be, this would be like the detail path, so dog/dog ID. And then we might want to edit dog details, update little fun facts about them, update pictures, whatever. So for that, we would have another subroute that's /edit. And here's what that route configuration would look like. Maybe our application is actually a little bit more complex. We've got a whole zoo of animals. We've got cats and dogs and maybe llamas and zebras, whatever. So for each of these, if we're following the pattern that I laid out before, we would have a separate routing module. And then from there, the routing module would load a different page level module for each path. So here's kind of a naive approach. It's very simple, super easy to set up. We're just mapping the path to the name of the module. You'll notice this is in quotes. This is how Angular works for lazy loading. If we referred to the actual class, then it would pull in the source code. So that's why it's a string here. Okay, so I load up my awesome page in the browser and I take a look at the network tab. And actually what I'm getting is a sequential load of 4 different JavaScript modules. So I've got the routing module, which I expected. And then I've got the list module and the detail module and the edit module. And this is not what I wanted, right? So We are not looking at the list module or the detail module right now. So this is a waste of time for the user. And even worse, these things are loading sequentially. So the problem before is that by default, Angular uses a prefix path match. So since I had this deep path, it was also loading the things above it. So the way that we fix this is by switching path match to full. And once that happens, it requires the entire URL. And so we only get that edit. This first routes is, that would be something that would be a little bit optional. As I said, this makes sense for us because we have 500,000 lines of code, and just even downloading all of the routes for our entire application would be pretty heavyweight. If you don't have an application that's so insanely huge, you could probably skip that part. Another source of sequential loads can be some of the route guards. So all of the can activate guards run before the resolve guards, and that actually makes sense, right? So can activate is usually used for things like authentication and permissions. So you wouldn't actually want to execute a request to get the details of an object if your user wasn't allowed to see them. So this all does make sense, but you do need to keep this in mind if you have really long-running requests. So if there are things that maybe aren't permission related and you don't necessarily want to activate a route, but you still want to download some data early. If you wanted to, you could even kick off some requests early and let them run in the background. So we've been playing with that pattern a little bit. Okay, the next thing I wanted to talk about was handling route errors. There's some sort of interesting differences between AngularJS and Angular in the way that navigation errors are handled. And those actually have pretty big effects in how you configure your application. Okay, so going back to our detail page. Imagine that we are trying to navigate from the dog list to the dog detail page. So normally we would set up a dog resolver that would take a look at the dog ID in the parameters, and then it would just call out to our dog service and get those dog details. Normally that just works as expected, but we do need to plan for errors. So ideally, if navigation fails, we would like to have some sensible error message. This probably shouldn't be a totally generic one. We might want to include something like the error code, so be able to distinguish between the dog was just not found versus there was a temporary server error, maybe could reload the page. We might want to display some additional information like the page you tried to get to. But in Angular, what happens is we don't ever actually see the browser URL update on failed router navigation. That is a significant change from AngularJS. So once that route resolver fails, the router is actually restored to its last pristine state. So what happens in effect is the user never sees the page transition at all by default. So they're left on the dog list page, they're left at the /dogs URL. This isn't really what we want because we want to be able to show the user that we did try and execute their request, but that it failed. So there are a few things to consider here. What do we actually want to display to the user? Do we want to have some sort of like modal pop-up? Do we want to display something that's just in the page? How would we support the user retrying their navigation? So if this is like a server timeout or some other sort of transient error, can we help them to get back to that page that they were trying to get to in the first place? Also, if we do redirect them somewhere else, is the browser history going to work as expected? And then from a very selfish point of view, what is the developer experience? So we were really having some problems early on in our Angular adoption where, so particularly if the route error happens on the initial page load, it redirects you to the root of the application. As a developer, if I screw something up and then fix it, I want to be able to just reload the page in my browser. And instead, I'd have to type the URL in manually each time. And I really don't want to do that because I'm lazy. So this is what we've come up with. So instead of allowing the router to restore the pristine state, we redirect to a dedicated error page. And here's what that code looks like. So we can just listen to navigation events, filter for the navigation error, and then when we catch one, we can save the most recent error on the error service. And we do that so that we have access to the error code and things like that. And then we navigate to our error URL. There's one interesting edge case here. Remember I said that the user might want to try and get back to this page. So as a user, when I see things break, I frequently just force reload the page. If we did that with this solution, we don't know what to display anymore because the error's gone. Our error service doesn't know about errors anymore. And it's really confusing experience to show the user, I'm sorry, we have an error that we're unable to find your error. So we didn't want to do that. So you might notice that the originally failed URL is in the query parameters here. And we're doing that so that if we think that the page has been loaded directly, particularly if there's no error saved in the error service, we can just try and redirect to that page. So as a super lazy developer, if I reload this page after I fix something that was broken, it will try and actually go to that page that had failed before. And if it fails again and goes back to the error URL, then that's totally fine. Just so long as you code a little bit carefully, make sure you don't have cyclical redirects. So this is what that error page component looks like. We get the error from the error service, we figure out what the error URL was, and then if we don't have an error, we try and navigate back to that original failed URL. Okay, I wanted to mention a few last things. These are a little bit more from the perspective of a migrator, but they are things that might also not be completely obvious, even if you're starting with Angular from scratch. So one of the first of these is that Angular has this great resolver API. You can map a bunch of strings to separate resolvers. But one of the limitations of this is in Angular, they can't actually depend on each other. So imagine that I want to display some information about both a dog and its breed on the detail page. So first we'd want to get the dog, and then we get the breed ID, and then we pass it to the breed service and get some breed information, except it turns out that this breed resolver can't actually access the dog because these things are completely separate and there's no way to set up a dependency relationship. So the easiest way to handle this is usually to just create a combined resolver. So you can have a single resolver that just sends back a map of data. And this does work really well. Another limitation of resolvers that at least was not obvious to me to begin with was that the resolver, if it returns an observable, it has to actually complete before the resolver will return. So if you imagine that I set up this resolver and it returns an infinite dog stream, and I'm just going to have this page that just cycles through dogs, it's going to be totally awesome. And then on my component side, I can just subscribe to this and bind it to the template, and it's going to be magic. Well, in practice, I'm just going to see my loading indicator forever because this resolver is never going to finish because it's just waiting for this observable to complete. So a way to do this that's more Angular friendly is actually to just go ahead and load up that observable and bind it to your component. And then in the template, you can use the async pipe. So this will hide the template completely and instead display the loading template while that current dog is null. And then once we get the first one, it'll show that template. And that let syntax allows us not to have to do that ngIf or add a question mark on every single access. So this is a really nice way to set things up, but it's very different from the way that we would have thought about this kind of use case in AngularJS. Another potential friction point with lazy loading is imagine that we have a dog service that's contained in a dog service module, and then we have two separate lazily loaded page modules. This is a really good way to make sure that we're loading absolutely the minimum amount of code needed. But it turns out in this instance, we actually get two service instances. So those two imports each instantiate their own dog service. And if this was something that we were using to manage state, we wouldn't actually see state pass between these pages. One way to fix this is to move that import up into the top level module. So in this case, we could put it in the routes module. You might remember this slide from the beginning of the presentation. This is actually one of the reasons that we set things up this way originally, so that if we needed to define some imports in the top level routing modules, we could scope that down to this section rather than importing that into the very core of our application. So that's everything. Thank you so much. Happy to take some questions, or if you want to ask me questions later afterwards, that's also fine. Thank you.